The Texas Department of Transportation currently relies on a contracted vendor for distress information, but data on concerns such as faulting lacks reliability and accuracy. Legislative reforms like MAP 21 and the FAST Act emphasize performance-based programs for federal highway aid projects. TxDOT and the Center for Transportation Research investigated precise measurement systems for identifying faulting on jointed concrete pavements that align with national performance goals.
Some of these concrete pavements, the so-called jointed concrete pavements, are built with joints that divide slabs which are about 15 feet or so in length. These joints, with time and with the action of traffic and the environment, start settling in a different way, and in between slabs, they develop a step. This step is what we call faulting, and as traffic is applied and time progresses, this faulting increase. There is equipment to measure faulting, but it's of two types. We have static equipment, but for static equipment, you need to apply traffic control, and it's very accurate, but it's very inefficient. On the other hand, you have dynamic equipment that estimate faulting based on surface profile. This is the opposite. This is very effective, but it's not accurate enough to develop these performance measures that we were talking about.
So the first thing that we did for the research is that they kind of evaluated existing tools, existing methodologies, what the existing history was of the measuring devices. And then they looked into ways to make improvements on this using some different methods, ranging from some point lasers to some line lasers, and eventually settled on a 3-line laser system that uses a kind of a 3D camera with the 3 laser line system. We now have a tool that we can measure the faulting and actually provide some results to federal highways where we really didn't have that method or didn't have that ability before. For the traveling public, we can do this at highway speed. So for all intentional purposes, the traveling public really doesn't see anything other than just a vehicle that's traveling down the road.
With developing this equipment, TxDOT now can measure faulting at the network level on an annual basis and can detect when this faulting is developed and apply early corrective actions.
What it does is it provides good feedback to engineers who maintain the roads, and they can ultimately make a smoother road.
Once we finished the research, and in this particular one, the product was a piece of equipment. This piece of equipment was delivered to the department. We have a training session, which we train a couple of members of TxDOT personnel members to use the equipment. The idea is now that TxDOT can monitor the faulting themselves with attached equipment to their own vehicles and monitor, or provide this equipment to the company that does a survey of the entire network. And with this information, the state agencies or state DOTs will be able, on the one hand, to manage the network to provide a network with a good level of service. But most importantly, or probably as important, we are meeting a requirement by the federal highway, which is in the transportation bill. So this needs to be done.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.